So whatever we're talking about, one pizza, one cheese stick, what? Okay, so I guess maybe it will matter more if I get out a pizza, or okay, maybe not a pizza, but if I at least get out a cheese stick. I have one cheese stick, right? I have one. And the question is, how many people am I going to divide this cheese stick like up into? Now, so I'm probably going to share with Miss Hassanein, and then, of course, Mr. Combs and Mrs. Pettigrew over there, and Mr. Estes is really far away, so forget about him. He's got his own fridge. And then Miss Howard. So if I split this to 5 people, right, that will make the bottom number 5, because this, what do we call this bottom number? The denominator. So, guys, let's go ahead right here. Denominator, not the terminator. So if we make this 5, what is that telling us?
You have 5 out of 8. Well, you have 5 of the cheese.
We have taken this and cut it into 5 pieces. Right, so let's go ahead and cut this cheese stick. Cut the cheese. So count your boxes across. Guys, you're like, I'm trying to be nice this year. We normally would have had to draw all this stuff. I did a bunch of your work for you already. Count the boxes across and figure out how to split it into fifths. So another thing that we can talk about, the denominator, is it's the pieces we make, right? It's the pieces we make or we cut into. So most pizzas come in 8ths, right? But if we're going to cut the cheese into 5ths, you should have counted 20 boxes across. So if we are going to highlight 1/5, I keep misplacing my green highlighter. 1/5 of the cheese. So this is how much I would get, right? If I'm going to share my cheese with my co-teachers, there's my 1/5.
But you don't have to, so why would you share?
So, common fractions, and because I'm now recording, I may not let Professor Van Schmohat keep talking. Oh yeah, it's this window. So, we said denominator. Ooh, we didn't write anything for the top. So let's, at the top of our notes, write numerator. And then, so wait, if my numerator is 1 and we made the denominator 5, what does the 1 tell me? The 1, so this is my cheese stick. And this is what I've kind of shaded as me, Grace.
Yeah, you have 1 cheese stick, and then the bottom is 5 and 5.
So the 1 is my piece, right? Out of the total pieces. So the numerator is my portion, right? What I have. So the numerator, how many I have, right? How many I have. Or number of pieces I get. So we could say that. Number of pieces I get.
Couldn't it be 1 cheese stick and 5 people?
Yeah, but so that will still mean the same thing. And then it's also, hey guys, you're about to get repositioned. And if you can't see well enough, it's just there's chatter, there's a lot of movement back there. So if you have a question, ask me. If you can't see, tell me to zoom in, but talking with each other isn't really helping. Another thing we can call it is our multiplier. So let's say Miss Hassanein and Miss Howard decide, Mr. Hudson, we don't really trust the cheese that you've had around your classroom all day long. We're not sure if it was kept cold enough. So they don't want any cheese. And instead of me doing this division all over again, I just decide I'm going to keep Miss Hassanein's piece and Miss Howard's piece. So what do I have now? 3 out of 5. Oh, hey, look. 3 out of 5. So if we were asked to convert this to a decimal, we might choose to do long division. Sorry, this is an arrow, by the way. I should have closed the left end to make it look more like an arrow and not like an equal sign. So, really, there's another way to... So 3/5 could mean... 3/5 could mean I'm going to get 3 of these out of the 5 that we cut it into, right? Or what 3/5 could mean is that I have 3 cheese sticks that I'm going to share with 5 people, right? So 5 lucky people. Cheese is on the floor. So I got my 3. So if we're going to long divide, right, and if we're going to make sense of what happens in long division, 3 is what we start with, 5 is what we're dividing by. So guys, if we go to type this in a calculator, which you're not doing, but if we went to type this in a calculator, it would be 3 divided by 5, right? That's what you would type in a calculator. But let's look at the long division. Can all of my 5 people get a whole cheese stick? No. Oh, sad. And if we're working in the standard mathematics that like most of the world has agreed upon, and I start cutting things up for decimals, what does decimals require? Tenths. So I'm going to cut into tenths. Guys, what that does in long division, this 0 puts a 0 here. We subtract, and then we say, well, I still have my 3 cheese sticks left, but I'm going to cut all of them into tenths. So now, instead of 3, how many cheese cubes do I have? 30. This is how long division works. We just keep slicing things up. It's long because it takes a long time. So now, I got 30 cheese cubes, right? How many can each of my 5 people... Well, guys, this step is literally 30 over 5. It's how many can I give out to each of the 5 people? Does this work out nicely? Yeah, it does. What is it? Anybody? 6. But remember, it's not 6 cheese sticks. It's 6 what? And 6 tenths, right? 6 tenths, or we could say 6 cheese cubes. Now, guys, what we've been practicing in chapter 1 is, could 5 become 10 nicely? How would it do that? Times 2. What does the top become? Which way is easier? Proportions. Proportions. Now, even though that way is easier, I do want to show you for when this is not nice, like when the denominator is not 5. So let's go ahead and look at the back of this. When the denominator is not nice. So guys, again, I'm trying to be better this year. I'm trying to give you a lot of like support and resources. When we're done with this page today, you're probably going to put it in a page protector to keep it nice and safe. I am a human and did not make this perfectly, so 1/2 we're going to bring over right here. Right, 1/2 is going to bring over right here. And I went ahead and showed you how nice 1/2 is. What are each of these cubes worth? A tenth. How many tenths is a half? 5 tenths. Let's go ahead and shade. So, guys, you can use highlighters and make this all colorful. And you could use different colors for each one. So, 5 tenths. Don't highlight too heavy because it will bleed through the paper. So, now this 1/2, we're back to our proper divisions or our unit fractions. So that 1/2 is like Grace and I are going to share this cheese stick. Right? 1 cheese stick to 2 people. The next fraction, 1/3, is like I hand this cheese stick to Sammy, Charlotte, and Lucy. So where do you think you'll get more cheese? With Grace and me sharing, or with Charlotte, Lucy, and Sammy sharing?
Well, I won't get any.
With me and Grace. Well, okay, yes, you're right. You won't get any cheese in this situation. But, so, how many tenths? So, guys, remember what we did yesterday. If I split this up into tenths, and I start doing A, B, C, A, B, C, A, B, C, how many tenths will each person get for sure? A, B, C, A, B, C, A, B, C. 3, right? So, first off, it's 3. And guys, if you want to grab a separate piece of paper and do a little bit of long division, this would be 1 divided by 3. We do not get any wholes. Now we have 10 tenths divided by, what is 10 divided by 3? Well, it's at least 3, but it's 3 something. What's 3 times 3? 9. So we just gave away 9 of the cubes, right? So let's go ahead and highlight 3 for person A.
We could only make the math easier on us and also get more cheese by just keeping all the cheese to yourself, you know?
Yeah, that's not how math works, though, and we're not selfish people. So, sorry, you can't just make it easier. Sometimes you have to do the difficult stuff. Now, hold on. So we said 3, but now what do I do in long division if I just have my remainder? This is the part that I don't love because people just memorize it and they don't know why. Caleb? Drop down a 0, right? And repeat the process. So drop the 0. If I slice, because guys, if you wanted to, and please don't do this with all of them, it will take you forever. This is like person A, right? Then person B gets the next set of 3. Then person C gets the next set of 3. And we have this 1 cube remaining. Remainder. Wow, look at that. So now we slice this cube into tenths because decimal, right? Deci, however you say it, means tenths. We have to keep breaking into tenths. Hey, Max, you're being weird. Don't touch other people. So, if I break into tenths again, how many can I give to, again, 3. So, again, 10 divided by 3, 3 and something left over, minus 9. Anyone feel like this is getting silly? Oh, it's a repeat. Oh, it's one of those. How do we write one of those? 0. Yep, 0.3. I write it a couple times and then I put the bar. Now hold on, make sure you highlight it to show that. So I need in this cube, I should really highlight like another third or another 0.3 of the cube. So maybe that. And then person, because they get 3 point, like 0.333, like they don't just get 3 tenths, they also get 3 hundredths. Right? They don't just get 3 tenths. So try 1/4. I bet you that one's a tiny bit easier to do on your own. Wait, you could what? I heard the J word. I heard the J word. What'd you say? Ooh, yeah, I agree, but I like hundredths because can 4 become 10 nicely? Not necessarily. Can 4 become 100? Gage, make sure that you're not being a distraction even though your notes are done. Make sure you're not being a distraction. So that would be times 25 if you take the proportion route. Me refocusing the screen. So wait. So 25 hundredths, hey guys, look right here at the top of the paper. The denominator tells us how far we go in the decimals. The denominator. Hey Charlotte, you got one last chance. I'm literally talking and you're turning to Sammy and starting like something. Okay? You're being disrespectful. Please fix it. I don't want to have to move you, but that's my next solution because it's distracting me and it's impacting my teaching. It's not just impacting you. Okay? Well, sometimes people make weird noises. So, 25 hundredths will stop at the second decimal place. 2500, which means 2/10 and another half or 5 hundredths, like another little. So wait, 2/10. So I got 2 of these. And then half, so like, then this, like 50 hundredths, or 50 whatever, yeah, I think, yeah, 0.25. And notice what's happening to our amount of cheese that we get. Keeps getting smaller because we're sharing with more people. Because we're nice and we care about our friends and we want to make sure that we share with whoever shows up. Do 1/5 on your own or with your partner. Do 1/5. And you can keep going. 1/6, we're going to practice long division again. So you might want to take a pen and kind of draw that like you went too far here, right? So otherwise, or just grab a different color. So actually, if you use a darker color to show that like 0.25 should actually just be 2/10 and then half of 1/2. Does that make sense? That this should stop here actually. So yeah, I think we accidentally went too far. So next one's going to go 2 of the 10ths, and then half of the next one is 0.25. I mean, you don't have to, you can just use highlighter. I just didn't have a ton of colors. These are all Egyptian fractions, so they all have 1 on top. Oh, I mean, that wasn't my plan, but I'm going to get that right now. You're kind of seeing deeper in my lesson than I did. 1/5. 1/5. Will it be more or less than 1/4? Guys, think about, like, don't just answer. Think about the question. When will I get more? Sharing with 4 people or sharing with 5 people? Sharing with 4. Like, think of a pizza. If you have a pizza with 8 slices and you have 4 people, that's great. We all get 2 slices. If you have a pizza with 8 slices and you share with 5 people, ooh, now all of a sudden we're fighting each other. Well, at least from what I saw at camp, you guys are pretty quick to fight about things. So, I don't know what color to use next. Purple, maybe?
Yeah, that's the one I chose.
So 1/5. Now wait, can 1/5 just work like... Oh, we did this on the back of this paper. What's 1/5? 2/10. So I just get 2 of my tenths. Still get less cheese, but this one's nicer.
I'm starting to see a pattern here.
I wonder if that was a mistake.
Nope, not a mistake. A masterpiece.
It's a masterpiece. Does it bother you that I have highlighter, pen, highlighter? Because it's starting to bother me.
Yeah, that's kind of annoying.
I regret that decision. 1/6, set up a long division for. And you can flip your paper back to the back. There's some space down here if you want. Let's set up 1/6. Baboom. Here's the back of my paper. Baboom. What color haven't I used? Blue, green. Well, yellow is not very dark. Orange. Yeah, let's do orange. Squiggly. 1/6. If I set up long division, what goes on the inside? The 1, the numerator. Hey guys, that's another trick of mine. Sorry, that really is just a trick. Numerator goes inside of the division symbol. The numerator goes inside. If that helps you, that is the only thing that helped me remember. It goes inside. And then a friend of mine was like, oh, the denominator's knocking on the door, right? They're like outside knocking on the door. That didn't help me as much. But if I have 1 cheese stick and I'm dividing to 6 people, can everyone have 1? No. So we put a 0 here. Put a 0 here. Do the subtraction. What do I do to the cheese stick since everybody could not have 1? I cut it into tenths. So now I have 10 pieces. Now, can everybody have a piece? If I have 10 pieces now, we have 10, like if we flip to the back, right, we have 10 pieces. Person 1, 2, 3, 4, 5, 6. Yeah, we can all have a tenth. So I'm going to go ahead and highlight one of my tenths. All right, so we get a tenth. If we give a piece to every person, how many pieces is that? A piece to every person. 6 pieces. A piece to every person, right? We have 6 people, 1 cheese stick and 6 people. How many pieces do we have left? 4, right? We got like 4 of our little cubes. 4 of our cubes left. Now hold on. So we have 4 cubes left. Because everybody can't have one, we cut them again. And when we cut them, guys, some of us forget how long division works. You need to be paying attention right now. I'm not going to ask you to long divide very much, but you need to remember how it works. So we cut again. Oh, my bad. I needed to put a 1 up here. Was anyone going to stop me? Nope. We need that 1 up here. From this 6, said everybody got 1 of the tenths. Now, we cut again. Thank you, Sammy. We drop this 0 because we cut them all again. Every one of these cubes became 10 little pieces. And now we have 40. If there are 6 people, how many pieces can we give each person now? 6. Because 6 times 6 is what?
36.
We subtract. How many pieces do we have left? 4. So we... Wait a minute. Oh, it's repeating, but not the 1, just the 6 repeats. So literally, your line should only be over the 6. We write this as 0.166. And guys, I would start repeating the 6 and then put the line over it. Because then you say, oh yeah, the 1 doesn't have the line, the 6 does. So right here, we need to highlight a little bit more. How much more is the question? Well, 60, like, guys, if you imagine that this square is 100 pieces, you're going to get 66 of them. Or if you imagine that it's 10 pieces, you're going to get 6 of them. So about here, probably, right? Just past that midway point, right? So then I'm going to highlight to fill it in. So you have 1/10 and about 6 more as we cut it into more and more pieces. Guys, 1/7, we're not going to do the long division with, but it's actually pretty cool. 1/7 turns into one of the coolest fraction decimal conversions there is. What's 7 times 2? What's 7 times 4? What's 7 times 8? Yeah, it's, so 14, 28, 50, yeah, here's the only difference. It's a 7 instead of a 6. So it does 7 times 2, 7 times 4, but then it kind of falls apart a tiny bit. It's 5, 7. But guys, again, your calculator's stupid. That 3 is a lie. That 3 is actually a 2. Because what number came after the 2? And 8. So that would round it up. This entire thing repeats. Literally the entire set of 6 numbers. Yeah. Now, after that super not nice one, we get a very nice one next. But hold on, we got a shade over here, right? So, do we get a 10th?
Yes.
Yeah, then how much hundredths do we get? Like 4, so like a little under half. So maybe like right here will probably be as far as we go. So a whole 10th. A whole 10th Whoa. I'm not judging your shading. Yeah, but it felt sarcastic. Can 8 nicely go into a 10? Can 8 nicely go into 100? Kind of, but the nicest is 1,000. Yeah, because do 1,000 divided by 8. Grab at least one of you. Grab a calculator. What's 1,000 divided by 8? And that's a whole number, right? Whole numbers are nicer to work with. So, guys, 125 thousandths. 125 thousandths. So, do we get a tenth? Yeah. Guys, notice how all of these are bigger than a tenth? All of these are more. So we for sure get a tenth. And then somebody said it. How much more? Half of a half, right? Because like 25, so like maybe like just right there, like half of the half. Or you could have done one of the squares, I guess. Yeah, good point. And our last one is one of the coolest. 1/9 really does have like a cool trick.
Yeah, isn't it like this weird thing when you multiply it that it gets like
Whatever the numerator is, repeats. What's that trick, Sammy? What's whatever the numerator is, it repeats. So 2/9 repeats 2, 5/9 repeats 5, 8/9 repeats 8. What breaks that rule is 9/9. Because what would 9/9 be? Just 1. So do we get a tenth? Yeah, we get a tenth. And then like a sliver, right? Like real small.
half of a half of a half.
I mean, don't use half because that's a mathy word. But like, you know, past a tenth, but not much. And your paper should look something similar to this. Oh yeah. Now up here is a nice place. Up here is a nice place to give a reminder. Can 5/10 nicely turn into something over 100? What would it be over 100? What about over 1,000? And guys, if you bring this over here, is 0.5 the same thing as 0.50? Is it? Yeah, because this 0 doesn't do anything. Is 0.5 the same thing as 0.500? Yeah, because these zeros don't do anything. Now, will 0.1 be the same thing as 0.125? No. You cannot say 1/8 is 0.1 when you actually know 1/10 is 0.1, right? Like, these are not the same. But if it's just zeros, zeros don't matter. Sorry, 0, the 8th grader matters a lot, but these zeros do not matter. Yeah, we keep getting less and less because we keep having to share with more and more people. I know, and I should put my cheese in my fridge before it like goes bad.
Can I have some?
No, because I don't have enough to share with everyone.
Well, we could. It would just take a long time and be
So pull out your homework. I wanted to chat about a couple of these questions. Yeah, you could grab a page protector for that if you want. So if you want a page protector for this, grab one. the first homework problem?
Interruption. Owen Burke, please come to the office. Owen, please come to the office.
Now hold up. You are supposed to have the decimal conversions written there as well. So you need to get those copies because we're going to use those like right now. Like literally, and then like don't keep this because I got to give that to Isa later. Guys, the Egyptians were onto something. I mean, they were onto a lot of things, right? I mean, they built the pyramids.
Not a college scholarship, but something.
So, I mean, I don't think college was that expensive back then.
I mean.
So, the Egyptians, every fraction they worked with was a unit fraction. It had a 1 on top. And you can actually do the same thing. Because any fraction, thank you, that doesn't have a 1 on top just got multiplied. Look at 211, question B, 29B. Yo, look at 29B. 29B is 3/8, and it asks us to make it a decimal. Well, 3/8, if I tell you that you get 3/8 of the pizza, do you think I'm giving you just like, so here's our pizza. Do you think I'm just going to literally like hand you a chunk that is one chunk that is 3/8? Like, all right, here you go, Charlotte. Here's your pizza. Like, no, right? Because how are pizzas normally cut? Into eighths. So what am I probably handing to Charlotte? 3 slices, right? 3/8. So what 3/8 is actually telling us is 3 times 1/8. Go ahead and throw this on your paper real quick, at least if you didn't do this problem yet. And we know that 1/8, because it's written down on that notes paper that you're going to keep safe in your binder, we know that 1/8 is 0.125, or we could say it more easily by just saying 125, and we'll just bring the decimal back in later. Guys, you don't have to work with the tough numbers. Make them easier, and then fix them, right? If I drop the decimal, I just have to make sure I bring it back. So, can I do 125 times 3?
Yes.
Yeah, I bet we can. What is it? 375, so just bring the decimal back where it belongs. That's how we can do fraction decimal conversions. If you know the Egyptian fraction, or the unit fraction, the 1 on top, you can just multiply by that number. Now, is that always the easier method? No. Because, like, imagine 3/7. Okay, so let's just multiply this by 3. What? No, I don't want to. Like, that's not always the best method. So, if you're given a fraction that is just kind of poopy, like 3/7, another option is in your calculator, you divide, because a fraction is a division. So if we do 3 divided by 7, it will give us the decimal conversion, but do not trust the last number. So 3/7, I don't think this is a homework problem. It might be, I'm not sure. But this becomes, guys, look up here real quick, because I know we talked about it earlier in the year, but now I might be able to actually blow your mind. You know how 1/7 was like 14, 28, 57? So is 3/7. It's just 14, 28, 57. It's in a different order, but it also is a repeating decimal using the same numbers in the same order. That's kind of cool. Okay, I said kind of. You don't have to repeat it and like mean. Gosh. I have like 2 minutes left. I don't know what the other kids were moving about, but I mean, you can like work on homework for like a minute or two. Or anyone have Well, so there was one other question people in the last class asked about.
You turn it.
Oh, so like on the back, I mean, if it's done, we're gonna check it, right? So you cannot turn it in yet, because we're gonna check it. We're gonna do our new homework goal, like our goal sheet. On the back, right? On the back, there is 5/99ths. Guys, think about this for a second. If I get 5 pizzas and try to share them among 99 people, or I mean, think even crazier, 5 cheese sticks divided by 99 people. How much is everyone going to get? Not much, right? Not much at all. But if you go to set up a long division for this, numerator goes inside, denominator goes outside, and we can start giving people very small amounts of pizza or cheese. Yes? Nope, not taking that question. Have a great day. See you later. Trying to let the cat out of the bag, William.
Like 99 is the skateboard and the 5 is the
If you wanna talk with William, you got to go talk with him yourself.
And then the 5 baseball.
Stop.
Over 99.
Oh well, you weren't giving away any secrets. Never mind. You were just trying to make jokes. I am betting that you're onto the right thing that you should be onto because you said the right words that I needed to make you stop. And that sentence was not a very good sentence, but I think you know what I mean.
What was 125,000?
Wait.
We can take more questions tomorrow. Oh, what is 125 times 3? So do 3 times 100 and then 3 times 25.
Or you can break it down into 100, 20, and then 5.
Well, yeah, but what's 3 times 100? And what's 3 times 25? 75, right? So it'll be 375. Gosh, all my cheese sticks are sitting out. Good gosh. Good thing cheese doesn't actually really have to be cut that cold. What?
Can I sleep this other one from yesterday? My mom can go there.
What's that? Sorry.
Can I sleep this other one too?
Can you start your sentence